Good day everyone, I'm Trixie Melumanda and today I'm going to discuss the concept of buoyancies and Archimedes principle. By the end of this lesson, we should be able to understand what buoyancy is, how it relates to Archimedes principle, and how we can apply it in real-life situation. So, our learning objectives are first, to understand the concept of buoyancy and its relationship with Archimedes principle. Second, apply the principle to everyday examples and real-life problems. And lastly, calculate buoyant forces using relevant formulas. So, what is buoyancy? Buoyancy is the upward force exerted by a fluid that opposes the weight of an object immersed in it. For example, when we swim, the water pushes us upward. That's buoyancy in action. Now, let's talk about Archimedes principle. So, what is Archimedes principle? It is an object submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. That means when an object goes into water, it pushes some water away, and the water pushes back with an equal force. This is why some object floats while others sink. The formula for finding the buoyant force is F sub B equals P times V times J, where F sub B is the buoyant force, P is the density of the fluid, V is the volume of the displaced fluid, and G is the gravitational acceleration. So, here's how the formula works. When an object submerged, it pushes some fluid out of the way. We call that displacement. The fluid pushes back when an upward force or buoyant force is equal to the weight of the displaced fluid. So the more fluid of an object displaced, the stronger the buoyant force it experiences. The formula F sub B equals P times V times J tell us the size of this upward force. So here's the example. Let's say an object pushes aside 0.002 cubic meter of water. Water has density of 1000 kilogram meter cube. Gravity is 9.8 meter per second squared. Plugging the value into the formula, F sub B equals 1000 times 0.002 times 9.8 is equal to 19.6 newtons. This means the water applies a 19.6 newton upward force on the object. Now, let's talk about how buoyancy works. If the buoyant force is greater than the object's weight, the object floats on the surface. For example, wood in the water floats because upward buoyant force is stronger than the weight. Next, if the buoyant force equals the object's weight, the object stays suspended in the fluid at a certain level, not floating or sinking. For example, a submarine can hover underwater at a specific depth by balancing its buoyancy with its weight. And if the buoyant force is less than the weight, the object sinks to the bottom. For example, a metal block sinks in water because its weight is greater than the buoyant force. So, we can see buoyancy and Archimedes principle in real life or application of buoyancy. Example, ships and boats. Ships and boats are designed to push aside a lot of water. This large amount of water creates an upward force that helps keep them afloat, allowing them to carry heavy loads. Submarines. Submarines can change their buoyancy by adding or removing water from special tanks called ballast tanks. When they fill these tanks with water, they sink. When they empty them, they float back up to the surface. So, to wrap it all up, buoyancy is the reason why object floats, sink, or stay suspended in fluids. And thanks to Archimedes principle, we can calculate and understand the forces behind these effects. This principle is not only important in science but also in real life, from swimming and ships to submarine and even hot air balloons. That's all.